Are you able to hear me? Hello. Right. So I think with the last few sessions, what we had, you're clear with respect to your constructive roadmap, man. Okay. Now, even though artificial intelligence also has some kind of fundamental terminology, man, but most of the time the terminology is mathematical. Okay. So when you take those mathematical expressions, whatever you generally speak in mathematics, that will become the terminology of AI. So you don't need to really worry about it. But machine learning terminology is something what we have to adapt. I'm not saying that practically you should immediately implement it, but without having proper jargon, you get into any area of your implementation. I don't think you find any great success happening in the process. So, certain terminology, what you should be aware and how you should be handling it, that's very important. We learn that machine learning is an add-on to the constructs what you implement in AI. Am I correct? Now, generally, whenever you're trying to implement any AI, man, if you take a mathematical environment, generally, I think we call that as a mathematical expression. Do you agree with me? Now, if you're expecting that your mathematical expression has to work again and again by taking in the data that is coming in, and it has to operate by itself, adjusting some amount of correction factor every time. So we are using one word called as learning here. Now, if you are having some information with you, and once again, next time, if certain information comes to you, then can you really expect yourself to learn everything in one single shot of your exposure? No. So every human being will have some level of learning rate. Am I correct? Hello. Every human being will have some amount of learning rate. Can you expect all the human beings to be having the same level of learning rate? No. But finally, on that learning rate, if we continuously concentrate and if we continuously repeat the process of understanding, definitely one day we'll start increasing the accuracy day by day. Am I correct? So machine learning is also in the same construct. We'll fix these learning rates and all these things. Let us not worry about that. But remember one thing, whenever we speak in machine learning, we say something always as a model. So first people should understand what is a model in machine learning. Now, especially the people coming from the database environments, when you say model, immediately their brain goes into what? Entity relationship model, enhanced entity relationship model. Yes or no? The same if you're talking to the data warehousing people, when you say model, their mind goes into the construct of what? Dimensionality model. Model in dimensions. Either it is in Snowflake or it is in star schema. If you're talking to a programmer in object orientation, if you talk to him in the form of a model, he says it is a UML diagrams, class diagrams, object diagrams, sequence diagrams, transition diagrams. He will consider those things as models. If you're trying to talk to a normal programmer working in sequential and procedural language areas, according to him, a model is what? Flowcharts. For a developer in databases, who is trying to operate on the data with respect to the construct of the flow and the process of the business, for him it is DFD, data flow diagrams. So don't you think that different people have different kinds of perspectives in model? The same way, when you come to machine learning also, we have a model. Don't ever compare this model with anything I told you previously, okay? If you don't do that immediately, you'll have confusion. I don't know you are coming from which area of your programming environments and technologies. So when you say a model in machine learning, a model in machine learning is one mathematical representation of the relationship between input variables and the target output. Is that point clear to you? It is a mathematical representation of the relationship between the input variables and the target output. So we have to first, if you want to build a model in machine learning, first you should build what? Come on. First you should build what? Mathematical expression. Mathematical expression. Am I clear? Now, when you say mathematical expression, gentlemen, it is not as straightforward as we take any simple mathematical formula. Okay. But just try to understand the construct what I'm trying to speak here. Okay. See, sometimes when I'm taking up my Excel sheet, you should be concentrative and you should be in a position to catch up with what I'm speaking. Okay. It's only to make your idea very clear and quick. Now, here, let us say I want to have an area of a place. Okay, this is my target. Got it? Are you getting me? This is my target, man. Are you catching up? Now, when you say area of a place, did he really tell you what is the kind of area he's expecting? You can have area of a square, you can have an area of a rectangle, you can have an area of a triangle, you can have an area of, say, like basically a circle. So, no, so many areas are there. Am I correct? Now, object should be very clear or not? If object is not clear, I can give you any area. Do you agree with me? So, first thing, very important is what? Object identification. Now, he's saying that area of a place should be represented in a shape like rectangle. Okay? He's saying that always it should be in the form of a rectangle. That's what he's basically saying. Now, once he said rectangle, then technically you're clear about the object means you should have the domain knowledge. Area of rectangle can be calculated in which way? Am I correct? Means are you not converting your requirement of the target, understanding the object into a mathematical representation in your brain directly? Means you're getting into your geometry now. Now, according to that, I think you need to understand the features. Am I correct? Now, if you want the features, generally features of a rectangle are taken by what? Tell me. One is the length. The other is the breadth. Am I correct? Hello. Any other features I need for a rectangle to be represented? No. But the general validation will be what, man? General validation. Do you have any validation for features of length and breadth of the rectangle. Okay, angle should be 90. That's perfect, Suyesh. Which angles? Corner angles, okay? Corner angles. The main important is length should be greater than breadth. Do you agree with me? Hello? Everybody should participate, man. It looks happy when everybody is participating. So don't you think that features have some validations? So when you're speaking about validations, gentlemen, I think these are all the things we discussed in the previous classes, yes or no? Then when you're taking validation, validation one is what? Angle. That too, it's not just any angle. If we are very clear, it's corner angles, yes or no? We are making it more specific. Should be equal to 90 degrees. Am I correct? Equal to 90 degrees. This is the first validation that you should definitely consider. Am I correct? The second validation is what? Length to breadth ratio. What is that? Length should be greater than breadth. This is the validation. If these two validations are satisfied, don't you think that you can think of going for calculations now? Now he is saying that you want the area of place by how much? There should be some target value or not? He's saying target. He's saying I want area of a place which should be in the form of rectangle. Now how much you want? You want the whole earth? You want the whole universe? You should specify a acceptable value. Do you agree with me? Now, suppose say like he's saying something like 100 square meters. Okay. The target value. There should be a target value for every AI and ML project. If anybody says that I don't know, but this should happen, now immediately leave that guy, man. He is half mad and he will make you full mad. Okay? Don't talk to that guy. You'll find some people, suddenly they'll get up from their dream and they will start explaining like a fiction of a science. And you ask, like, what exactly you want? You tell me, uh, I want that. What is that? Don't talk to those people. Okay? So there should be a clear value of understanding by that person. Now, he said square 100 square meters. Man. This is what he's saying. Means you go with any of these things and you operate, your target value is that. Now, I think the story is clear. Now, you should technically think of what now? Taking all these things, now you should fill a model. You should design a model now. Now, let us watch here. We need minimum inputs as how much, man? Tell me. We need minimum how many inputs? 2. Yes or no? One is what? The next is the breadth. Now, until you don't give these inputs, can you expect that to be achieved? Now, what is a fundamental mathematical expression you are expected to apply, man? The mathematical expression you are expected to apply is equal to the value in the length multiplied by the value in the breadth. Am I correct? So first you have to build that particular expression. If that expression is built properly, we need to check the target value is being achieved or not. Yes or no? Now this 100, is it equal to this or not? If it is matched, then 100% you don't need the next level calculation. Do you agree with me? Now, here you need a constructive state. You have achieved your requirement or not. Now, let me say that I give something, my length is 5 and my breadth is 6 now. It's giving only 30. Now, technically, how much loss is there? 70. So, every machine learning process, when you do, we have some loss value. Are you getting me? We have the loss value. Now, when this loss is coming, then only we have to specify. When this loss comes, that is the area where we are defining the learning rate. Now you cannot directly give the learning rate with a fundamental formula, man. Are you getting me? Now here loss occurred. So your loss occurred is basically with respect to what? Equal to our actual target is 100 minus this is the loss. Yes or no? Now, machine learning happens in one single level of training, or it's a process of happening through the training continuously. Training. But can you just expect this mathematical expression to change in each training? No. So now, suppose you have kept the learning rate as 0.1. Okay. Means my expression should start learning how to adjust itself to reach the corresponding target of 100 square meters by a learning rate of 0.1. Means, don't you think that here I should go on adjusting my length and breadth by taking this learning rate as a criteria and then complete that particular task simultaneously very slowly till that particular values are adjusted to get this loss to be 0 and my final target to be 100? Yes or no? That input values along with the mathematical expression adjusted to the loss and learning rate, if it is working again and again, that technically becomes a model, man. Are you getting me? Now, can we learn straightforward mathematics and say it's machine learning, man? Straightforward mathematics is what? You want 100 square meters. Then technically, if you are giving your criteria of this length as suppose like 25, then what will be the breadth we will give? 4. Now, this is straightforward mathematics. Are you getting me? Means by using artificial intelligence, what you can say, get me length of 25 and then breadth of 4, apply. Now you go to ask your client now, are you okay with length 25 and breadth 4? If saying that 25 is becoming too long, breadth is becoming very less, it's better you adjust it with something else. Then you're saying that, okay, then I'll make this 20 and then I'll make this 5. you're going on adjusting the formula. So no, I'm saying 50 and then I'm saying 2. If this formula is successfully operating, but can we expect the real-time inputs to come like this directly always? No. I'm getting my length, suppose say like something like 32.65467. Why it should not be a float? Then what should be the breadth? This learning rate will tell how you go on adjusting this in such a way that anytime any kind of length and breadth comes, the learning rate can apply the process of algorithm and your required target can be calculated. Am I clear? So in AI, we always have known values, yes or no? But in machine learning, the data will come from where? Real time. When that real time data is coming, technically, are you achieving your target or not? If you're not achieving, every time, if 1,000 values are coming, 1,000 values are coming, let us say, then 1,000 values, can you say each value will be same with the next one? No. Whatever value may come, you should apply the learning rate in such a way that your learning rate continuously applied on that particular value. Say like first time when you came, see my learning rate is 0.1 only, no doubt. But I am checking the loss of adjustment. According to the loss of adjustment, I am adding that learning rate to my length and breadth. And if I adjust the values and if I apply once again, don't you think that my loss will decrease? Now my loss has decreased by say like 2%, but not target goal. Don't you think that using the 0.1 learning rate, the new values of the length and breadth, if I adjust once again, it becomes 100 somewhere after 100 times or 200 times of iterations or not? Sir, how much learning rate I should decide? These are all factors. Means how slowly you want to make your system to learn such that you can track every time it is doing a mistake very easily and adjust the learning rate. So learning rate has no special kind of value, man. Am I clear? So try to understand this. So machine learning needs a different kind of mindset of thought process, man. Else you will have great lot of trouble. Therefore, I can do logistic regression. Everybody can speak about algorithm, man. But finally, your conventions of the terminology are correct or not. So that mathematical representation, what you are providing with all the loss functionalities, learning rate implementations, number of epochs that should be happening. Epochs means iterations, under which that model always can give you the expected target value for the input values, whatever you are supplying. That representation finally becomes a model. Means you'll take that expression of functions, you apply them, and any data you give as input, automatically this mathematical representation of expressions, they adjust those values in such a way that you always get the target value. Am I clear? Can we put straightforward mathematics and try to get into machine learning? No. But mathematics, can we keep aside and start working with machine learning? No. Sir, I am not a mathematical student. That is where the advantage of Python comes. Are you getting me? Is that point clear? Uh, Rajesh, you cannot take like that because here we are giving the values from our side, no? That's where understanding hyperparameters and all these things are very important. Why I started the terminology is only for that, okay? You should always validate, no, Pinto. When your data is coming at runtime in live, without validation, can you push it into the expression directly? Only after you do validations, only you'll come to know whether those inputs are acceptable or rejectable. Am I correct? Pinto Singh. That is the challenge, Asutosh. You have to definitely decrease the loss. But how you define a learning rate, that is also dynamic, no? That's what I said. Did I say learning rate is fixed? How to adjust your learning rate also dynamically is one of the biggest challenge here. Are you getting me? See, one topic when your teacher is teaching you, you understood with 30 minutes of discussion. Another topic, can you expect that you can understand only within 30 minutes of discussion? Hello? No. So don't you think that even learning rate is also dynamic value here? But somewhere we have to fix that particular value and we should start or not. And I think that is the area where I discussed 2 points in my starting classes. Can you just recollect and return me back? When I was discussing the types of machine learning, I discussed one very two important points there: overfitting and underfitting. Do you remember? So if your learning rate is not decided properly along with the construct of your input and validations, don't you think that your model will go either overfitting or underfitting? So can we work in machine learning directly with a standardized construct of straightforward values always? No. Why? Because you technically do not know what values will come from runtime. So adjusting your model means optimizing your model is so complicated. Finally, any value in the universe it comes, it should have the ability of achieving the target value. If a formula is there, Ranveer, it could be very easy for machine learning and deep learning. Can you tell me any formula for you to understand what your teacher speaks? No, it all depends. Yesterday you learned some topic very fast. Let us say like in 15 minutes you understood and you explained. Your teacher is saying, wonderful man, what an intelligent person. Next day, he or she told you some 100 times, but then also you're having confusion. Don't you think that the opinion of the teacher has changed automatically? I never thought that you're such a dumb. But why is it that yesterday you were able to capture in 15 minutes and next day you're unable to capture even after 1 hour? Generally, students will say, sir, it is a tough topic. No, you could have been psychologically influenced by many things. Before the class has started, something really disturbed you mentally and you lost your peace. You are half consciously participating in the class, listening only 20%, wavering off yourself. Sometimes your mind is so inactive, you're thinking you're listening to the class, but you're not at all listening. Even if you're listening, your mind is not. These all things, can we have any formula? Can we have any formula? No. That's where machine learning and deep learning, if you want to make them think like human beings, do you think that the general mathematics will help directly? That's where we said a heavy lot of parameters, heavy lot of parameters. Here I have taken only how many parameters, man? Here I have taken how many parameters here? Just two inputs and maybe two validations here. That's all. So taking this example, don't try to make out everything in machine learning. Are you getting me? I gave you an example to tell you that how you should think about a model in a very complicated way. Is that point clear? First time beginners, some small confusion will be there, but don't worry. But I want only you, see, I want you people to understand the rule of complication here. People think that machine learning is a straightforward process. No, you should psychologically get ready for it. Else, actually, introducing terminology here is waste of time. But without terminology, I can directly speak in algorithm and I will apply, and you will also feel happy because it is finally I will decide what is the input data. No. So machine learning model is created by applying an algorithm. This model always is applied by an algorithm. What is that algorithm? Algorithm, what you are defining, will have so many number of different components and constructive expressions. This all together, which is becoming a mathematical representation, will start working on what? The training data, learning patterns, and making predictions. Means whatever model you have created, that model will be applied. That model will be applied on training data. As your training is taking place, some kind of adjustment is happening, yes or no? Because the data is dynamic, your target is standard. No doubt, target is not having any kind of wavery. But imagine your client is saying, I want 100 square meters, but plus or minus approximately near to that in 10% is saying. Okay? Are you getting me? Now, once he says plus or minus 10% in approximation to its actual value, means he's ready to adjust the output of your target by underfitting and overfitting also. Am I correct? Now, if you are reaching nearest to that 90% accuracy also, is he saying that it's okay for me? Achieving 100%, it's good. But he himself has said that my risk factor of accepting the target is minus 10%, he said. Means even if you are achieving up to 90 square meters also, I will take. That's what he's saying. Yes or no? So technically, you're giving the training data. Now, training data, whatever it is coming, according to that, you're pushing the learning curves, let us say. Now, training data, if it is straightforward in integers, it's okay, man. If it is coming in floats, don't you think that always you'll have some kind of wavery of the accuracy? So, how your machine is learning means each time you push it into the process of execution on that model, what is a pattern it is taking to learn and adjust the corresponding state of values to the target of what is expected, and at what level it is expecting that if you give this combination of data in the ratio, you can always achieve that criteria and composition of 100 square meters. What is happening, what predictions it's doing. So your mathematical representation of the model is always created by understanding the training data, learning patterns, and predictions. Am I clear? So remember, a machine learning model could be as simple as a linear regression or as complex as a deep neural network. Algorithm can be anything. So every time you talk about some algorithm in machine learning, this algorithm, when you apply through the mathematical process, what it defines, if you can achieve to the construct of the target, then this algorithm with all its components of mathematical representation will become a model for me. Am I clear? Which can be as simple as linear regression. It can be as complicated as deep neural networks. That is the reason every machine learning guy should definitely speak in the interview rooms. For his implementation, he said he has executed what algorithms he has implemented. Am I clear? As you're explaining your algorithm, you're explaining your model. First, understand that. As you're explaining your model, you're explaining your mathematical expressions or representations. So, this much of mathematics, do you think that at the age of my 30, 35, 40, I should do? I'm not telling you to become a core mathematicians, but at least those packages, what you will use with respect to construct of your Python, don't you think that you should be in a position to explain the package with its methods and all those things at least? People will come and tell us when, okay, in interview and say, I did a project on autonomous vehicle. It's really fascinating, no doubt. And if your interviewer is a sarcastic guy, he'll say, like, how many autonomous vehicles are running which you have designed on the road? Don't you think that's a very depression based question now? You'll immediately get depressed. Once your psychological state is going negative, even after that if after that is asking you, can you tell me exactly what is a formula for finding the area of a triangle? Gone. Finish. Because he started like that. So talking about that autonomous vehicle is very easy, man. But what are the different algorithms you have used? What machine learning algorithms you have used? Mathematics behind that is exactly what you don't know how to explain your mathematics. At least explain the packages from your Python very properly. Am I clear? Catch up, catch up. So a machine learning model is the end result of training an algorithm on the data. Okay. Once you train your algorithm on the data, whatever you're having, where you fix it that this prediction always looks perfect to the output what we are expecting, then we are finalizing that as a model. So a machine learning model is the end result of the training of an algorithm. The final machine learning model is a set of learned parameters that can be used to make predictions. I'll simply ask you one question, man. Okay. You're feeling feverish, man. Okay. Indians are self made doctors mostly. Don't you think that you're going and having dolo? But technically, do you know what is happening internally to your particular body? For anybody, your friend is having fever, you'll become doctor. If you are staying in a hostel, if one person went to the doctor and came back, the same symptoms are there, he becomes a doctor to all the remaining people, giving the same medicine every time. Means that particular tablet is just like a model. Are you getting me? Internally, it is having fundamentally different kinds of chemical combinations that will work definitely in the similar style, almost all predicted to keep your disease down. So, what your machine learning model contains? It contains a set of learned parameters that can be used to make predictions. Learned parameters means features with values. Okay. If these are the kind of inputs, this is the kind of situation, these are the circumstances. Okay. These features, if you adjust in this way, you finally can get the target that is expected. Try to understand one thing, man. Are you not really trying to control your psychological state of your reactions and relations and communications with the people in your social environment by only adjusting the set of learned parameters with your own experience or not? Just imagine how much we should think on the domain to adjust these learned parameters such that you can always make a proper prediction. You take straightforward intelligence and you are ready for machine learning, but are you adjusting your mindset to understand these things that are expected? So machine learning models can vary in complexity depending on the type of applied algorithm, domain of implementation, size of the data being analyzed. Depending upon these three factors, the complexity definitely will be variating. So can we say a machine learning model is as straightforward as what we know about models in the construct and composition of the day-to-day experience what you had in your software career all these years, man. Taking that, if you're entering, you have some small confusion. And here model is represented in the form of a diagram anywhere. Is a model is represented anywhere in the form of a diagram here? No. But all the models you learned with respect to your experience in software side, they were purely diagrammatical. Yes or no? But in machine learning, your model is represented in which way? Mathematical expression. Mathematical expression. Now, expression can be a single line or expression can be a derivation of multiple steps to finally achieve the corresponding result. Yes or no? Go back to your schools where you are working with the concept of algebraic expressions, derivative expressions. There, didn't you take your pen and paper and worked for achieving the result in multiple steps and then concluded? For students coming from intermediate with mathematics, I think you could have been discussing with your friends saying that, oh, this differential equation man on the construct of expression took 2 pages for me. Means those are all steps of operating by scenario and the situation of understanding the feature in the previous level. Yes or no? Means those are all variables. I'm not scaring you, but understand the model of machine learning very carefully. Don't get confused. Am I clear? Trust me, model definition out of 10 people in the market who say they know AML, man, they can't explain. I'm definitely expecting my students to technically keep these points in your brain. If a question comes, can you tell me what is a model in machine learning? And then he's just asking like, which model you have been implementing in your project? Means you should answer what? Tell me, which model you have been using in your implementation of your project? What you should answer? The corresponding machine learning algorithm. Okay, machine learning algorithm. Satyendra, it's not just a mathematical expression. Okay, mathematical representation, not expression. Okay, so you should explain the corresponding algorithm. If you said, sir, I use linear regression as one of the mathematical representation of the model for this problem of ML, then you should be in a position to explain at least what components of the linear regression. Components of the linear regression. Nobody is expecting you to write that mathematical formula. Okay, because you're not a core mathematician. At least components of the mathematical expression of the linear regression you should explain. Means you should at least have the clarity of this linear regression library is available where, and this library has what kind of linear regression class will have what kind of methods, and these methods what kind of parameters they will take, which are defaulted, which are basically expected to provide. At least this you should explain to your interviewer or not. Why I'm stressing is you have to change your learning methodology, understanding methodology, and presentation methodology also when you're attending interviews of AI ML. Okay. Simply, I want to ask you one question, Pintu Singh. For any problem you have with a target, what you should achieve, can you expect only one specific expression can always give you the target result? Hello. Definitely not. Yes or no? So there is a chance that a model can be a combination of multiple mathematical representations. Do you agree with me? Part of it can happen with linear regression. And once it is achieved, that is first level. Taking that into the next level of learning process with a neural network, maybe I'll get the final result. Today, ensembling, we call it as ensembling means what? Making multiple models to work together to give you the final target. Can you expect autonomous vehicles to work with only one particular type of model? No. So that's where what I said, your second level, when you take your machine learning to deep learning, didn't I say that it is layers? Yes or no? Deep learning is multiple layers. Is there any rule that all the layers should be of the same algorithm? No. Is your brain is taking decisions on only one particular type of thought process? Same thing. No confusions here. Am I clear? Satyendra Singh, AI agent is not exactly part of the machine learning. It is an end product of machine learning, which is already having certain algorithms in place, which are kept in a workflow. Okay? Which is an end product. That's the reason people are moving towards AI agents. Why? You have certain tools today. You drag and drop and you apply. AI agent construct or agentic AI, whatever we are speaking, can be done in the market today very easily. But who can develop AI agents? Who can develop AI agents? Tell me. People having core knowledge of AI, ML, and DL. Are you getting me? Yeah, definitely. Definitely, Ranbir. Is there any rule that one single formula can solve all your mathematical requirements? No. Keep it very clear. Sorry, understanding the dynamic construct of liquefied state of thought process we should develop in ML. So I will teach you each algorithm, let us say. Each is one algorithm I'm teaching you. But can you say that with that algorithm, the problem will be solved in every domain? No. So are you understand the model seriousness now? This is what I want first of all. This change in your mindset and thought process should come. You leave it on my shoulders, what models we will build and how we'll go through practicality. Okay? You don't worry about that. I'll take care of it. But are you clear with the models simplicity and seriousness what you should take? If that's clear, the next terminology what you should learn in machine learning is what are features. Okay? What are features? Tomorrow we'll put pressure on this. Got it? Thank you very much for your patience, man. Because to keep yourself ready to listen to these areas needs great lot of patience. And I appreciate that. Because you have it, I'm able to discuss this. Thank you, gentlemen. Once again, with you tomorrow. Have a nice day. Take care of yourself. Have a great day. Absolutely, Ranbir. Absolutely.